Okay, dear friends, we are going into see how to traverse a graph. We know by definition, a traversal means visiting every node exactly once. So in a graph, there are two traversal schemes commonly used. First is called a breadth first search, next a depth first search. As the word implies, the process is clear. So if I have this graph that we have seen, we have put its adjacency list here. That means for every node, its adjacent nodes. A has got B and C. So similarly explained here, the adjacency list of representation of the graph. Now in a breadth first search, we begin with the first node, let's say A, then find out all its neighboring nodes. So A, B, and C. So A, B, C. Then, since there are no more neighboring nodes, then we go to the first in the list, that is B after A, and find its neighboring node. So that is D. And actually, we should go to C. Now, C's neighboring D, we have already completed, visited. Then go to D, D's neighbor E. So this is what is called the breadth first. So A, span out all its neighbors, then take the first, its neighbor, then take the second, its neighbor, already finished. So this is what is called a breadth first. And in case of a depth first, we again begin with the first node A, find its neighbor B, and find its neighbor, that is D. So A, its neighbor is B, B's neighbor is D, D's neighbor is E. The graph is over. So A, B, D, E. It's over. Then we go back to the first node, find its second neighbor, that is C. So write C. C's neighbor is D. D is also visited. D's neighbor is E. E is also visited. So now, in order to implement these two, we will know. Okay. Now in a breadth first, we use a queue, meaning when I take one node, I push all its neighbors into a queue so that it can come out one after another. And in case of a breadth first, in case of a breadth first, I use a queue. In case of a depth first, I use a stack. So depth first uses stack. Do not get confused. Algorithm is practically similar, only terms, words popular to the two will have to be used. So we'll just have a look at the breadth first and the depth first search algorithms, which this is a most probable theory question. So let's have look here. This from this graph, I have created the adjacency list. This is the adjacency list. So this is the graph traversal breadth first algorithm. So breadth first uses a queue. So the terminologies are particular to queue. So we have a graph that is given breadth first, given graph G represented by adjacency list. So this is what is input we have in hand. Start is a starting vertex, in this case A, more probably. What returns, program returns nothing. And the variables used, we have an array called visited of the size equal to number of vertices. So here it is 5. So we have an array visited having size 5, positions put from 0. Then we have a node to mark current, which stores the address of the node as the adjacency list. So current vertex being processed per adjacency. If I am processing B, that will be B. If I am in C, C. Then Q is the queue used for storing vertices, and V is the vertex that I will be in process. I do not know whether I should go through this algorithm. If you can implement it, try out here, would be the best. So begin this. So we initialize a queue empty. Then we mark every vertex as not visited by initializing the elements of array visited. That means I just mark this as not visited. That means from A to E, all not visited. Then we are going to start with the first vertex, that is this, okay, that is vertex X. This will be visited, so I will mark this as visited, means put 1, then add that vertex to the queue. So this vertex gets added here, the first vertex, that is A. Then while queue is not empty, I'm going to delete the node. So this node will come out. So I get the node A out. I'm going to print it. That's going to be my result. The delete node, print it. Then current becomes, so my first node, current is first node of the adjacency list of vertex V. That is A's first node adjacency list, that is B. So current will become B. Current is B. Then while current is, what I'm going to do is, now I'm going to move in this direction and check whether these are visited, because A's neighbors are B and C. So what we have seen. So we take out each one, and now V is the vertex contained in current. That means A. This is a node. Okay. Current becomes B, and first node, that is list of V. So this is current. Then what we are going to do is, we are going to find all its neighbors and check if it is visited or not. While current is not, so I'm going to process this entire list while as not equal to null. If vertex V is not yet visited, B is not yet visited, so add vertex B to the queue. That means this is actually gone, but I will add here. B will get added here. B, Q, mark vertex V as visited. That means V is B, second one, this is visited. Then current is equal to next. Actually what happens, it goes to the next, C gets implemented here, gets implemented, and proceeds. And when the list is over, that means when this, while current is not equal to null, that means when this list is over, it goes back to this. So what it does is, it will delete the first node. This was already gone. It will delete the first node from here, B. It will delete the first node and print this. So B is printed, B, and current equal to first node, the adjacent list of V. So that is, this is V. So B is now, this will become the current. That means current will now become V. So it will proceed and take its next adjacency list and proceed. And if you work, you will see next C will come out. After that D will go, D will come out, E. So being in Q, it brings one out. So you get the result as we saw in the first. So in a breadth first, you will get the order in this graph A, B, C, D used because of the Q that is used. So a commonly used question, I would ask you, take this explanation, look at the algorithm and work against these steps, and I'm sure when you use these diagrams and mark them, arrays, and if you work, you will see how finally you get the result in breadth first search. And similarly also when you go into the depth first, the only difference is terminology is stack terminology. So here it is stack, that means here will be push and pop, and the first one that pushed last comes out. So you get here, for example, when you proceed, you will find A's neighbor B, B's neighbor D. See, this is how you get pushed into the stack, and they come out in that same order. You can get A, B, D, E because they are popping out. For example, just one clarification, when we are using depth first, I can get this in two order. I can get A, B, D, E, or I can also get A, C, D, E, B. Both are correct because I'm using this. Sometimes when you do the practical, we will get in this particular format because A, B gets pushed, and sometimes what comes out may be A, B, C. So it can be A first, this path, and last D. Or you can also, both are correct because both are depth first. So this is a probable question in theory exams, and depth first, breadth first, or what are the traversals, explain any one of them theoretically. Kindly make sure that you go through this. Thank you.